Hello everyone, welcome back to our series Publish Your Own Library. So today a little bit of refactoring, so we want to have our library a little bit more flexible and easier to test because, spoiler alert, next week we will do testing. Like and subscribe if you enjoyed the video as usual, and apologies for my voice, I got a cold, so I hope it won't disturb you too much. Enjoy the video. Alright, just a quick recap. So last week we just finished printing our trees, so our ASCII trees. So we calculated the necessary length from children to parents, and we also put the correct pipes at the end. So have a look to the video, all the video, if you need a refresher. So as you see, our print function is not really friendly to test because essentially it's just logging, so there's no value to test against. So it's not very flexible, and also we don't give choice to the user to choose the logger, or maybe the user doesn't want to print or to log, so maybe he just want to store it in a CSV or JSON or whatever. So essentially we will offer the maximum flexibility to the user. So I'm starting changing the signature, maybe returning an interface error, so returning whatever the user of that library will want. So if I'm starting changing that, it's a good idea to think also to provide an interface, because if a user is using our library in its code, it might need to mock or to replace it or to provide its own implementation later on. So if you remember correctly, we had a package called interface, so we will just create our printer interface there to make things more flexible for the user. So there you go. So yeah, I don't know why I deleted, so put it back, interface error. So we want that signature, that function in that interface, so we don't need Timber interface because we're already in the package Timber interface. So essentially we're providing that interface, and we're also providing an implementation of that printer. We will just call it custom printer. So we will provide a very flexible printer. So as I said, we want to let the user provide its own printer function, logging or storing function. So we call it printer function, but we can't let everything loose, because at some point we need to manipulate like not display and tree display, so a display string. So here on line 20, it's declaring a function type, so printer function, which is a function taking a display string and rendering an interface and error. And our custom printer will have to have one of that function. Okay. So the print function we implemented last week or several weeks ago, it's now a receiver method of that custom printer. So I'm just changing the signature there. So you can see that print and do print are now receiver methods. So if I want to use do print, I need to use printer.doPrint. Okay, so far so good. So let's just invoke our printer function here. So it's gonna be printer.printer function, and we need to send a display, which is a string. So we will just use formatting .sprint, not .display and tree.display, no worries, and then send it to our printer function, because our printer function takes one argument. Don't worry about the errors and the returned value for now. As usual, when you change something, do baby steps. So Here, that's we want at some point to try that out without breaking things. Usually you would have test to cover your back, but that's okay. It's just for learning purpose in that case, so it's okay. So here I just use quickly a constructor function. So then I can declare a printer. So it's the timber package, then the generator function, and we can call printer.print on our printer, and we need to provide that printer function. So we just declare it above. So if you remember, it takes one argument, a string, and then returning an interface error, a tuple. Alright, so here we won't return anything, that's okay. But we want to just log as it was doing. So then we're sure we didn't break any behavior. Okay. So here just whatever it's receiving display, we will just log it. And then you can see the user can use the most convenient library that she wants. And we're just sending that print function to our printer generator. And then you can see we didn't break anything. It's still logging. But it's now the responsibility of the user to provide that function. Okay, sound good. You can see here I returned the display in the function. You'll see why in a few minutes. Okay, so now in order to let's just do that quickly, just handling that error. So just call it display result, returning an error print for instance, and then we will do something with error print later. It's okay. Just leaving a to do, so then you don't forget what to do. We won't do anything with the result yet. Now we're in a recursion loop, so if we want to store result, we can provide a field in your custom printer. So we will just call it result interface, and we want to aggregate results. So as you go through the recursion loop, you want to do something with the result as it goes. So here, same trick, we will define a result function. So here there's a little function trick. You see I wrote previous result, comma, current item, and then I declared its type, which is interface. So it's a shorthand to say previous result interface, comma, current item interface. Okay, so you can see now the custom printer struct has result, which is an interface, and result fn, which is a custom function type. I'll just change quickly the generator of the custom printer, and then we come back to where we had the result of that printer function, and we will aggregate the result. So it's very generic. It's got a reduce function. It just that result function is just taking the previous result and the current result, and the user can do whatever she wants with it. So as far as we're responsible, we're just sending the current result, which is printer.result, stored in the struct, and then we're sending the current result. So here I have a variable problem. You saw that I had trouble to name that one. So display result, print result, it's not really accurate. So we can come back later to that. It's not a problem. So essentially what your result function is returning is an interface and error, and that interface is your updated result. Okay. And as good practice, you saw that I'm constantly returning an error, so it leaves room for the user to provide a resilient function with error checking and error control. Okay, so then from that custom function, we have the updated result, and we just change what's stored in the struct. So printer.result equal updated result. Okay, baby step as usual. Let's try it out. So here I'm returning a string, so the result will just be a slice of string simply. So I'm just initializing a slice and then providing the result function. So the signature is slightly more complicated, so taking two interfaces and returning an interface and error, so I just copy paste it here. Okay, so essentially I just want to, because the result is a slice, I just want to append the current item to the previous slice. So because those are interfaces, I need to cast them. So previous result is slice of string and current item is a string. So here I just wanted to try if we could cast string like that. It didn't work, so it's fine. I'm just putting back current item dot string to cast it into string. So simply like that. So I'm just appending result. Okay, so I want to try that out. So nothing happened because we're not returning that result, printer.result from that printer.result function. That's not a worry, we can fix that. So you can see doPrint is not returning anything. That's okay. Our result function is transforming it and storing for us, so we will just change print to return the result. So doPrint essentially can return just an error, so now we can deal with those flow. So if there's an error from the printer function, we will return that error. If there's an error to the result function, we will return that error. You can see ID is complaining because the signature is incorrect. There you go. So it's doing the recursion, and if it's all good, it's just returning nothing. And then back to the print function, we can just control that there's no error back from the recursion loop. There you go. I just use by ID shortcut there. You're just checking if the error is nil or not. It still is displaying nothing, it's fine. We can now print the result from the .print function. Yeah, we can just panic if there's an error and just log the result there. Okay, so you can see it's logging a slice, which is, well, you can't see it very much. So I turn off the logging. So if I write a quick range loop, there you go. So we can range through the I, which is the result of the printer.print. You can see that my ID is complaining because I is an interface, so I need to cast it to a slice of string. There you go. And there you go. It's our tree stored in an array, and I'm printing each item, and it's working really well. It's storing for us in the correct order through the recursion loop. Okay. Okay, so there's a few refactoring and helping operation we can do for the user. So custom print doesn't need to be public because I don't want people to instantiate a custom printer and sending, like, for instance, no function and having a panic. So I'm not gonna let the user having the choice of instantiating with a nil function, so making it private and then providing default printer function and result function. So there you go, you can just replace it by default printer. Then we can do the same with the result function, which will be the default. So for function, you don't have the choice to use const, so I just use var. So I'm just essentially refactoring from the main. So you have now a default result function and a default printer function. I can use that. Okay. So what happens if the user forgets to instantiate the slice? There you can see there's a tiny problem. Nil is not a string, so it's trying to cast something which is nil. So it's line 26 basically. When I copy pasted, I forgot to return the display. So here, if I change that returning display, you shouldn't have any casting error. There you go. So then running it, and you can see everything is working as intended. Okay, so we have a new custom printer, and you can use default printing function and result function. So there we can go even further. So we have that constructor new custom printer, which obviously that's what we wanted to do. So the user can send its on printer function, result storage, and result function. But if someone just want to use the default logger of that library, we can provide another constructor, new default printer, without taking no argument, and we are constructing the custom printer for him. So exactly the same as we are using in the main.go. So the default printer, 0 slice, and then the default result. So then here we can just invoke new default printer instead of new custom printer. So there you go, and still working as intended. So essentially, if someone wants to use our library, timber.new default printer, providing it's free and it's working. If she wants to use the custom printer, that's fine, it's available for them. There you go. Alright, hope you enjoyed that little refactoring exercise to give flexibility to our library, because next week it's testing, so stay tuned. Happy coding, everyone!